Look out into the dark void of deep space, and you might spot this, a perfectly straight, glowing streak of newborn stars. In 2023, an astronomy team pointed the Hubble Space Telescope at a distant galaxy and stumbled across an object that completely defied categorization. Looking at this scale diagram, we can see the anomaly stretches for nearly 200,000 light-years. That makes this single streak roughly twice the length of our entire Milky Way galaxy. The problem is that gravity usually pulls matter into spirals, clusters, or spheres. A perfectly straight line at this massive scale points to a highly directed force. To figure out what drew this cosmic line, scientists either had to discover an entirely new type of galaxy or confront a physical process we've never witnessed before. The Discovery team first thought this might be a super-thin galaxy positioned perfectly edge-on to Earth, but the light profile didn't match. Standard galaxies contain a mix of older red and younger blue stars, whereas this streak was entirely composed of young, hot blue stars. The data revealed an intense energy signature exclusively at the very front tip of the trail, a concentration of doubly ionized oxygen that only forms in the most violent environments. With the thin galaxy idea out, researchers tested a second theory. Maybe a neighboring galaxy fired a powerful radio jet that triggered star formation along its path. This comparison chart shows why that doesn't fit either. Standard jets start narrow and widen as they travel. This anomaly does the opposite. Also, a radio jet loses energy the further it travels. Here, the strongest interactions are happening at the farthest, narrowest point. Standard cosmic phenomena couldn't explain the shape, the stars, or the energy. The culprit had to be an extraordinarily powerful object moving completely unseen through the interstellar medium. To get a higher resolution look at the tip of the streak, astronomers secured time on the James Webb Space Telescope. The new data revealed a massive, supersonic bow shock plowing through the gas of deep space at 1,000 kilometers per second. There is only one object compact enough and massive enough to generate a wake this violent without emitting its own visible light: a runaway supermassive black hole. This discovery forces us to ask how a black hole, an object usually associated with total annihilation, is acting as a catalyst for creating stars. Look at this model of the bow shock. Moving incredibly fast, the black hole doesn't consume the gas. Instead, it violently compresses it. As it barrels forward, that gas flows into its wake, rapidly cools, and ignites into millions of new stars. This runaway object reveals that a supermassive black hole is capable of seeding the cosmos as it moves, acting as a violent engine of creation. By following the trail of stars backward like a cosmic dotted line, researchers traced its origin to a distant two-galaxy system known as the Cosmic Owl. 38 million years ago, this system experienced an incredibly rare event. Two massive ring galaxies collided perfectly head-on. As these two galaxies physically merged, their central supermassive black holes were drawn together by immense gravity, eventually spiraling into a single combined entity. We can see the ejection mechanism here. The merging black holes released an asymmetrical burst of gravitational waves. This lopsided energy created a massive recoil, shooting the central mass out. The kick completely broke the host galaxy's gravitational hold, launching it into intergalactic space. It took a perfectly aligned collision between two of the rarest galaxies in the universe to weaponize a supermassive black hole and shoot it into the dark. Back in 1983, physicists proposed the math for a runaway black hole, but this streak of stars provides the very first observational proof that they actually exist. Black holes are clearly more mobile than we assumed. They aren't always anchors at the center of a galaxy. They can be nomadic. With wide-scanning tools like the Nancy Grace Roman Space Telescope preparing to launch, astronomers are looking for more of these trails. By pairing these advanced telescopes with machine learning, scientists will actively hunt across the sky for these faint, straight stellar signatures. The J0437 galaxy and Able 2261 cluster are already missing their central black holes. we are likely on the verge of uncovering an entire hidden population of rogue, star-creating anomalies. The universe's most violent, destructive scars are secretly the chaotic engines birthing millions of new stars in the dark.